Jim here. So today we've got this multimeter. Doesn't have a lot of description on it other than saying it's an intelligent digital multimeter. This is something that I've received from Amazon through the Vine program. So Amazon provides me this item for free. I need to review it. So let's have a look at what's in the box. What do you get for an intelligent digital multimeter? Okay, so in no particular order, there's the meter itself. And of course, I'm not sure what the brand is on this. We'll figure that out. But this is referenced as an FS2202 9999 counts, 4 nines. Okay, now I haven't put the battery in here yet, so we'll have to put the battery in. And interestingly enough, okay, a lot of stuff comes out of the box. Okay, so there's some instructions here. Now, the funny thing is, in the box, if you can see that, it says accessories, which is true, but this doesn't come out. You can't tell, but I'm kind of pulling on that pretty hard. So a little bit weird there, but it is what it is. So like I said, there's a user manual. Has a lot of information in there. There's this must be the temperature probe, right? So right there's the tip sensor there. So that's what a temperature probe typically looks like. Here we have the typical probes. Okay. Does not feel like silicone. Wouldn't expect it to. But a good set of probes. And of course, they don't stick out of the unit. They go into the ends. Interestingly enough, oh yeah. Okay, so you can see here that common goes there, the input for the other values goes there, and amps and milliamps get measured through that jack there. So there's 3 jacks at the bottom there, and then the top, there's some lights and the sensor. Whoops, some lights and the sensor for the non-contact voltage. If I bring it up to the lens there, you can see what's going on there. Has a nice feel to it. Sort of good rubber. Although it doesn't have any kind of a bail or a kickstand or anything like that. So it's always going to be used lying down or maybe held up in your hand. You're certainly never going to be able to use it other than lying down. So now it also did come with, I forgot to mention, comes with a pair of batteries. So that's always sort of, at least as far as I'm concerned, a nice touch that these come with some batteries, because you may not have the batteries required lying around. So that's a nice touch. So let's look at putting some batteries in there. We'll see if this has my favorite battery feature. If you watch the channel, you know that I like to see a brass collar here where the screw goes in. And hooray! Look at that. Nice brass ring there. Whoops. I like to see that because otherwise you end up chewing up the plastic pretty quickly with these screws. Okay, so let's get the 2 batteries in there. Shrink wrap that they put on these is pretty tight. Okay, so 1 battery there, like that. 1 battery there, like that. Okay, put the cover back on. Okay, that's fastened in, and let's turn it on. Oh, there you have it. Power's up. Auto. Okay, sorry about the glare there. And so, I guess it's telling me that it's 18 Celsius, which is interesting. And then you can see at the bottom here, all kinds of different symbols for the different kinds of measurements that it can have. So the next thing we're going to do is we're going to hook up these probes, and well, you don't want to see me struggling. There we go. With the probe. So one probe goes there. Okay. And the other probe goes there. Now you can see that these probe tips, they've got a lot of shielding on them, caps, to, you know, for safety reasons. But I'm going to take those caps off for most of what I'm doing with low voltage electronics. These don't serve a huge purpose, and they're a bit of a pain. Okay, so there's the probes. Now these, I think that says these claim to be Cat 3, and they can manage 1 kilovolt. You can see that there. And they've got the typical set of certifications here. But yeah, set of probes. And of course, we'll have to figure out how to make it work. But there you have it. There's the first step. So we've got them hooked up, and probes installed. And now we're going to go and put it through its paces with a bunch of measurements. So now we are going to take this FS2202 meter, and we're going to put it through its paces, meaning we're going to take a bunch of measurements and see how well it does. And of course, if you want to know how well something's working, you have to compare it to something. So my reference point, what I use for comparison, is this Fluke 117. I kind of use the Fluke as my gold standard here. And so anything that comes close to the Fluke, I consider to be pretty good. And if it's not very close to the Fluke, well, you know what that means. We consider that to be not so very good. So let's see how this goes. Let's get started. So we're going to start by looking at DC volts. And the way we do DC volts, we got a battery here. It's not a fully charged battery. Let's turn that on. Now, one of the things about the FS2202, this meter, is that it's a part of this new breed of multimeters that are fully automatic. And what that means is, you know, you don't have to put them into a range or anything. You don't have to tell them what units, what type of thing you're trying to measure. So if we're trying to measure volts, we don't have to set it into volts first. We just go ahead and measure. So let's do that. Okay, now one of the things you should pay attention to is how long it takes to actually do the measurement. So we've got the probes. It's measuring the ambient temperature. It's kind of cool here in the studio, let's say. So let's put that on. And so you can see kind of jumped around a little bit, but right now we're at 1.498, 499. And so if you're watching closely, you see that it first kind of jumps to what I would say is an incorrect reading, and then after a while it goes to the correct reading. Now, one of the things that we can do is we don't have to rely on the unit to do everything on its own. We can say, okay, well, we're going to measure volts. So it takes a while to get into that. We'll assume that's volts. And so if I do that, it's much faster, right? So much faster. Oops. Okay. So that's something to kind of recognize, that you can use it in that fully automatic mode, but it takes quite a while, and it may give you some false readings beforehand. So we were getting 1.499 volts there. The Fluke, of course, we have to dial it into something. Let's look at what we get with the Fluke when we measure this battery. 1499. So the measurements are pretty much the same, right? 1.5, 501. So within a few hundredths of a millivolt for what I'm generally doing, for what most of us are generally doing, those hundredths or thousandths of a millivolt, not hundredths of a volt, or 1 or 2 millivolts. Not a big deal. Okay, so happy there with the DC voltage. Now let's give it a try on resistance. Okay, so let's put this back into auto, and I've got my little handy dandy resistor there, and if you can see that, yellow, violet, orange, and then gold. So that's it's a 47 k ohm resistor. So if we put it in auto and measure, thinks for a while, but eventually it comes up and it says, yes, okay, that is indeed 46.2 k ohms. Okay, so we'll do that again, just so you can see the speed, the response speed. Thinks for a while, 46.2. So let's take the Fluke. Same thing, but this time, of course, we've said it's ohms. Oops, am I not touching the... You have to touch the thing you're testing. 46.37. So a little bit different there between the Fluke and the 2202. Let's do that again with the Fluke. 46.36. 46.37. So pretty quick, but the values don't quite agree. Okay, so we're about 10 ohms. No, that would be we're about 100 ohms off. In the 46 in the k ohm range, maybe that's not such a big deal, because that's well within the tolerance of what we'd be looking for anyhow. I will say that that may be a little concern. Okay, just for the heck of it, we'll bring in a tiebreaker Just give me a second. The leads are all tangled up here. So I've got a unity here. I know, lots of meters here. I'll just put that somewhere where we can see it. Let's ohms. Okay, so that's set to ohms. You can see that says 0. So let's now measure this. 46.32. Okay, so the unity is saying 46.32. The Fluke is saying 46.37. And the 2202 saying 46.2. So 46.3 is what I would go with, given that the unity and the Fluke are pretty close to each other. So 2 out of 3 we'll go with the majority opinion. So there's no way to actually put this directly into an ohms mode. Okay, resistance only. So you have to set this into auto in order to measure resistance. Okay, because when we go into the mode that shows us the ohms, you can see maybe at the top of the display there, there's also a little symbol for continuity. So that's going to tell us about the continuity. So since we're on that topic, let's measure continuity. So this is one of the things where the Fluke is just totally awesome. So if we're in continuity, okay, you can see that. Pretty good, right? Generally gets all the taps there. The Fluke has a similar awesome behavior. Fluke never misses. What's interesting is if we set this to full auto, okay, there we go, full auto. You don't want to clearly measure continuity with this device on full auto because the responsiveness is not really there. See, it takes a while. Okay, so that's something to be aware of if you're working with this unit. So continuity, you won't want to use it in full auto mode. Full auto mode, you can use that certainly for measuring resistance, but you wouldn't want to do it for continuity. Now, let's measure AC voltage. So we'll measure a couple of things. So we've got the end of a AC plug there. We'll turn that on. This is one of those things where we say, kids, don't do this at home. So we're going to take that, and we know the middle one there is going to be ground. We'll stick this in here, and this in there. And there, you can see it takes a while, but it's telling us it's 60 hertz and 121.7, 0.8 volts. And of course, it's red because generally it wants to tell us that that's a dangerous amount of voltage, and we should not be fooling around with that. Okay, but it did take a while, right? So we're going to put that in there again. Okay. And so you can see, I mean, you're seeing me insert the probe there. It takes a while to turn off, but it takes a while. one of the things that I wanted to show is what happens with this FS2202 depending upon what the mode setting is. So you saw how it works when it's in auto and I do the AC voltage. So now let's see what happens if we are in, this shows volts mode. So it doesn't say DC or AC, it just says V. So let's put the probes in here. Okay, and after a while, it goes back to auto, as you saw, and then it detects that it's AC voltage. Okay? Now, let's suppose, so it's gone back to auto on its own, there's another setting here. Now that's clearly DC, so that's not going to help us. But this is AC, and it says AC millivolts. So what happens if it's AC millivolts and I plug this in? Well, if it's AC millivolts and I plug it in, it doesn't do anything except say that it's over range. So it doesn't reset on its own. So that's an interesting kind of behavior. Now, just for reference, I've got the Fluke. It's set to AC volts. You can see that that's pretty quick. And the lightning bolt on the Fluke in the corner is what tells you, see in the upper left, that's what tells you that it's a high voltage. You should be concerned. Okay. But we knew the Fluke works well. Now, let's try another thing here. Live. So the live setting is intended to allow you to figure out which wire is the live wire. So if you hit the neutral, okay, see, so that's the live. Now it's pretty quick and responsive. Watch this again. Okay, very quickly. Now if I put this in the neutral side, nothing. Okay, so this is a common feature that is appearing on a lot of multimeters now to do a quick test to figure out which wire is the hot wire or the live wire. Okay, so that's very fast. Now, that's for measuring temperature. We'll get to that. Auto. Another thing that we can do with this meter, there's some stuff here where we can activate backlight. Okay, so I haven't had that on for most of the thing, but I'll leave that on now. And we also have some settings here. There's a hold setting. And I mean, I'm sure everybody probably knows what hold does. It'll just hold the amount, the value. Then we have a flashlight. And so that can be handy if you're, maybe you have the power off or you're trying to look into an electrical box and see what's going on. So you got some 2 LEDs there that provide a little bit of illumination. I mean, it's not super bright, but it's better than nothing. And if it's dark, it would be fairly helpful. And then, of course, for non-contact voltage, you have to hold that down. Okay, and it says EF. And you've got to get the wire close to the probe, the sensor. So non-contact voltage requires you to go into a special mode. Okay, so back to auto. If we hold it on, it says, and it does say NCV there in the bottom corner. You can see that. And when we bring it back into proximity to a live wire, get that. All right. So We've looked at continuity. We've looked at resistance. Oh, see, that's a live wire. Okay, and the Fluke also has that capability, although I don't tend to use. You can see it's much more sensitive. This is, see, at that same distance, the Fluke is showing me the field. So, okay, we'll just turn that off. So I would not, although the non-contact voltage works, it's not really super sensitive. So you've got to get right up to the wire to sense it. Oops, flashlight. Okay, back to auto. Let's look at a couple of other things here. So we have this will measure capacitance. So look in my junk bin here. I have a capacitor. This capacitor, I think this is 220 microfarads. Let's see if we can get to focus on that. So that looks like 220 microfarads. So if we connect the probes up here, yeah, so it's reading DC volts, which is not really what I'm interested in. So you can see that the auto can kind of take us a little bit astray. That's not so great. Let's put this into, so here's capacitance mode. And eventually 220 microfarads. So it works, but I think that's really slow. You've got to have a lot of patience for that. So let's compare that to what we can do here on the Fluke. So just got the probes in the right order. Okay, so ready. Whoops, I put it in diode check. It helps if you put it in the right mode. So now it's in capacitance mode. Okay, 220. Let's get this wire out of the way. I'll do one more time. So you can see a lot faster. You know, if you're doing this, well, you shouldn't be measuring a capacitor in circuit anyways, but you've really got to be patient and make sure you've got a good contact on those leads with the FS2202. So now let's do our diode check. So here's a diode. Okay. Once again, we've got to pay attention to where the silver band is. That's going to be our negative. Okay, so okay, so that's got diode check and voltage. Got the two probes here. Let's get this out of the way. Get that out of the way. And so what this will do is it'll tell us the bias voltage. So you can see here. So that's pretty quick. Okay, so 220. Sorry. Well, I guess that's 225 millivolts, 0.225 volts. Okay, so that's pretty quick on the diode check. We'll compare that to what we see here on the Fluke. Put this into diode check mode. That side, this side, and of course the Fluke beeps when it detects the diode. So and you can see that the bias voltage is registered a little lower, 200, 203, 204 millivolts, as opposed to 220. But usually when you're doing diode check, you're not really super concerned about the accuracy on the millivolts. Well, temperature, you can see that it's been measuring temperature the whole time on that bottom readout. So let's take the temperature probes and we'll attach the temperature probes. So we'll unplug these. So this has got the standard kind of thermocouple here wired in. Of course, wires get hugely tangled. Okay. Okay, so now I've got the thermocouple in. Okay, so you can see that that's reading, and of course it's reading it in Fahrenheit. Right now it's saying it's about 60. And if I put it in my fingers, it starts to warm up. And the bottom readout is now showing the Celsius readout for the thermocouple, 23. Well, I'm warmer than that. 24. Might take a while. My fingers are really not that hot. So you can see the temperature works. Most fingers are warmer, so warming up more. It's hard to say exactly how hot my fingers are. In general, when you're using the thermocouple like this, you're generally looking for large swings in temperature. You're not looking for these aren't really meant to be super accurate. So it does work, although I do think it's reading a couple of degrees lower than it should. And the last thing that we need to try out is we need to try out the current measurement. And so I've got to get a circuit here that'll let me measure the current. We have a little circuit here. It's a very little circuit. I think I don't know what I stole this out of, some sort of light of some kind. Anyhow, it's hooked up to the bench supply. I've got that set to 3 volts. And we'll make sure it doesn't put out more than 500 milliamps. Not that it's going to need 500 milliamps. So if I turn that on, you can see the LED lights up. Kind of what we'd expect. Now I'm first going to measure the current going through the circuit here with the Fluke, and if you can see the readout, see when I measure it, the LED gets a little brighter. Oops. Okay, so I'm on AC amps. That's there, that's there. Sorry, not AC, yes, DC amps. Okay, and once the probes make contact, you can see I've got about 19 milliamps going through there. Okay. Now, that's one of the reasons why you want things to be pretty responsive, because it may be tricky to get good contact. Now, what I want you to notice here is I've got the black is plugged into the common. Now, when I take the red probe, and I'm going to take this, as soon as I plug this in here, watch what happens. Okay, that knows right away that I'm connected on the amp side. So now it's no longer sort of it may auto range, but it's not going to measure voltage and all kinds of other things. This is only set up now to measure amperage. And so let's do the same thing here that we did with the Fluke. And get these probes in place. 1, 2. Okay, and you can see 17, 18, 19 milliamps. So pretty much the same as the Fluke, although it seems to be wandering a little bit all over the map. Whereas when I do this with the Fluke, we can turn the light on there too, I guess. You know, it is rock solid, steady. Okay, so the readout you get here is correct, but it sort of wanders, as you can see here. 18. Okay, well, maybe it was my fingers wiggling. I don't see. 16, 17, 16, 18, 19. So it's reasonably accurate, but you need to really make sure you've got good contact, because it's not gonna, it sort of seems to be a little bit susceptible. Whereas when I do this, I mean, I know the probes are a little different too, but when I do this with the Fluke, assuming I'm touching the things I want to be touching, you can see that that sort of just locks in pretty quickly. All right. So I think I've gone and taken that through pretty much all the paces that I intended to go through here. We've done AC, DC volts. We've done resistance, a little bit of continuity. We've just done the DC amps. I'm not going to do AC amps. It's not something I do a lot of. You saw when we were doing the AC voltage, we saw the frequency, the live currents detection, non-contact voltage, temperature, capacitance measurement, and diode checks. So we've pretty much done everything that this has to offer. So what's the conclusion? Well, I'd say in summary, it feels good in your hand, but the responsiveness on some of the measurements is just really sluggish on some items. And you know the things that I'm spending most of my time doing with the meter, I'm generally measuring DC volts. I'm measuring the resistance. I'm doing continuity. Well, the continuity is not really super responsive. The resistance takes a while to lock in. So it works, but I really prefer and I'm sure you would too, the performance of something like a Fluke or something that really was a little quicker and a little more responsive. It's nice in the sense that you don't really have to you know, when you put it into, oops, I can't put it into auto mode because I'm in amps, but it is nice, sorry to shake the camera there, to have an auto mode where it'll kind of figure out what you're measuring, but you pay for that in terms of response time. Well, you know, you've seen everything this can do, so you'll have to kind of draw your own conclusion. You know, maybe for the price, and if you don't want to fiddle with the dial all the time, maybe you'd be willing to deal with that. But generally, I would probably go and find something a little more upscale, a little more responsive. Although, like I say, it is a very nice, it's a very nice unit to hold in your hand. All right. Well, thanks for watching. And if you like these reviews, please subscribe to my channel. Bye for now.